Hey class, so today's going to be the first lecture on 2.6 formulas and problem solving. Let's just get the pen so that way I can write it. There we go. So in formulas and problem solvings, our objectives are to use the formulas to solve problems, but also solve a formula or equation for one of its variables. So these are going to be the formulas that we're going to come across. And right off the bat, you should recognize area. The area of a rectangle is just length times width, but we have some new ones that maybe you haven't seen. Simple interest, perimeter of a triangle, distance, volume of a rectangular solid, and degrees of Fahrenheit and degrees in Celsius. So let's look at examples and see how we're going to deal with specifically this distance formula right here. So we have some examples. Here's the first one where it says, a glacier is a giant mass of rocks and ice that flows downhill like a river. Portage Glacier in Alaska is about 6 miles, or 31,680 feet long, and moves 400 feet per year. Icebergs are created when the front end of the glacier flows into Portage Lake. How long does it take for ice at the head, beginning of the glacier, to reach the lake? So, in word problems like this, personally, I like to highlight where we see numbers. So right here we see a 6 for miles, we see a 31,680 feet, and we have 400 feet per year. Those are the only numbers that we see. But then we want to look at what is the question asking at the end. So how long does it take? Okay, so this is a question about time. And the numbers they give us are distance, 6 miles, and the 31,000 feet, and they also give us a rate, so feet per year. That is a rate. Okay, so now that we have all of our numbers highlighted, our question highlighted, and we've associated each of these numbers with a word or variable, now we can start to look at our formulas and see if there's any one that we can use. So if we look at our words that we've written down, distance, rate, and time, we see that this formula that I kind of hinted at earlier, distance, is going to be the formula that we're going to use. So when we see d equals rt, we know that the distance that we're given, 31,000 feet, is going to be on the left-hand side of our equation. And then on the right-hand side, we have rate times time. Now, they're asking for the time. So we're actually going to leave that time alone. We're just going to put in 400 feet per year in for the rate. So now we have 400t. Okay. Now you might ask, why did I put in 31,000 for the distance and not 6 miles? And the simple answer for that is because this rate right here is in terms of feet per year. So the rate is telling us, okay, we want our distance to be measured in feet. So that way we can easily divide or multiply or do whatever in order to get a time. So when we do this, we're just going to take the natural step that we've been learning about. So we want to get t alone, and in order to do that, we divide both sides by 400. If we take out our calculator and type in 31,680, hit divide, divide by 400, we get that the time is equal to 79.2. 79.2 what though? Notice how each of the variables that we've plugged in so far have had units. This one had a unit of miles, this had feet, and this had feet per year. So if we look at it, we see that the rate is going to be 400 feet per year, and the distance is 31,000 feet. So by process of elimination, we see that time is in years. So it's going to take 79.2 years for this glacial to move. Here we have a second example where we want to calculate the length. So it reads, Charles Picou can't afford enough fencing to enclose a rectangular garden with a perimeter of 140 feet. If the width of his garden must be 30 feet, find the length. So again, I'm going to do the same thing that I did last time. Whenever I see a number, I'm just going to highlight it. So we see 140 feet and we see 30 feet. Okay, so what variables are these numbers associated with? Well, we have the perimeter of 140 feet and we have the width of 30 feet. And lastly, we want to know, what are we trying to solve for? And at the end it says find the length. So the length L is what we're looking for, and we're given the perimeter and width. If we scroll back up to our formulas that we have, we see that we have a perimeter right here, but this is of a triangle, so it has 3 sides. Whereas the perimeter of a garden that they're talking about in that problem is going to be the length plus width plus length plus width, or perimeter is 2L plus 2W. So I guess we didn't have to go up here, but I thought it was here. So let's go back down to our example and solve it. So now looking at the formula that I derived up there, we can see that P, the 140 feet, is on the left-hand side. On the right-hand side, we have 2 times our variable W plus 2 times our variable L. Okay. So now we combine like terms. We just distribute this. I should say we distribute this 2. I don't know how to erase with this, but it's going to be 60 right here. We subtract 60 on both sides, and we get that 80 is equal to 2L. Lastly, we divide by 2L, or 2, sorry, to get L alone. Sorry, this is kind of all over the place, but we get L is equal to 40. So the length of this garden is going to be 40. But again, 40 what? All of these units are in feet. So this is in feet. Okay, so that's going to be it for this video. Hope this has helped, and you won't have to do homework on this until Monday. So for right now, this is just the introduction to this section. On second thought, I might as well do an example using degree measure, using these temperature measurements. So let's look at this example really quickly. The average minimum temperature for July in Shanghai, China is 77 degrees Fahrenheit. Find the equivalent temperature in Celsius. So if we look at our formula sheet, we're given a Fahrenheit and we want it in Celsius. So we're going to use this formula right here. F is equal to 9/5 C plus 32. So writing that down here, F is equal to 9/5 C plus 32. Okay. So our measurement is in Fahrenheit, which means it's going to be the left side of the equation, and we want to solve for the equivalent temperature in degrees Celsius. So we're going to be solving for our C. So plugging in our F, we have 77 is equal to 9/5 C plus 32. We want to get our C alone, so we subtract by 32 on both sides, which is 45. And we multiply by the reciprocal of 9/5 on both sides in order to get C truly alone. So 5/9, 5/9. And when we do this, we get 45 times 5, so C equals 225 divided by 9, which is equal to 25. So the equivalent temperature is 25 degrees. And that's it. That's the last example for this section. Okay, see you next time.